22 says tangent squared tan squared x equals tan of x plus 6. Okay. So I know that, and if you've seen Avatar, you know what I mean. When in the movie he says, I see you, like he really means I see you, not just like the outside of you. But anyway, I see that this is a factoring problem. And so it's difficult for me to explain how I see that if you don't already see it. But what I see is that I can't take the inverse right here because then I'd have tangent in a square root. Yes?
I saw that. I just didn't know what to do after.
Okay. So, but since I'm recording, I just wanted to start there. So since you've agreed that it's factoring, I'm going to move everything to the same side. And then make my parentheses, and then factors of 6 that make -1. So -3 and +2. Okay. Okay, so class agreed. It's factoring problem. There it is. Now what do we do? So in this group of problems, remember I did that example yesterday where I said you may not know things? So I said in 21 through 30, you might have problems that had weird answers in my video yesterday. So what that means is if I say tangent of x equals -2 and tangent of x equals 3, I don't know what either of those are. Might I know a half? 2? That one we might know. That would be like, no, a half over 1. That's not it. I only know 1 and square root of 3s and 0. That's all I know off the top of my head, making fractions. So instead, what do? To solve it algebraically, you take the tan inverse of this side and the tan inverse of this side, and then you write x equals tan inverse of -2. Was that the answer? 22. Isn't that how they wrote it? Yeah. So this was the answer. Did I have this on the paper? I hope so. So it's a weird looking answer, but this needs a calculator. How do you get to the part where you can use a calculator? You do the math, because otherwise, I mean, you could do a graph and find it, Ben.
I just was confused how you knew -2 and 3 were in the domain.
Because tangent looks like this, and every y is covered. Every y. Because I that's something that when we talked about domain and range, and I mean, I didn't make y'all regurgitate all of that, but maybe I should have. But
I just couldn't remember.
The domain for tangent is it has an asymptote at every pi over 2. So x is not equal to pi over 2 plus k pi because it's got a period of pi. Couldn't come up with that. Did you see me? Anyway, but the range is all real numbers. So it covers every y that there is because the line goes up for infinity and goes down for infinity. It should be straighter here. It shouldn't cross the asymptote. But that's beside the point. But when you see it now, do you see it could be anything? So tangent is not limited by the -1, 1 because the ratio is such that you can, as you get closer and closer to pi over 2, so as you approach pi over 2, tangent is going like this. The x value that's on the bottom, I'm going to try really hard. I can see this again like Avatar. Hopefully you can. As we go around the unit circle, as we get closer and closer to pi over 2, where the value of cosine is 0, right? We're getting closer and closer to this. We can't ever get here. We're not allowed to get here. This is a no-no. But as we get closer and closer, so we're here, x gets smaller. We're here, x gets smaller. We're here, x gets smaller. When we're infinitely close to pi over 2, x is so tiny that when you divide by a tiny number, the actual division gets a big number. Am I making sense?
Yeah.
So that's why the asymptote exists. This is a huge calculus idea. So if it is starting to click, then that's fantastic. So anyway, it's the nature of knowing that tangent has every possible answer. And I only know the ones that have square root of 3 in them, 1 or 0, because those are the only ratios that I know on the unit circle. So this was the one that I did the example for yesterday, because this one you'd have to use a calculator for. So this is how you type it in a calculator. Like if you say, calculator, I need an answer, like tell me what 2 plus 3 is, and it would tell you 5. How do you type it in? You have to type it in by using the inverse tangent. And its stuff is switched. So its inverse looks like this, where the highest value is pi over 2, this pi over 2 part, and the lowest value is negative pi over 2, but the domain for it, this value, is all real numbers, right? This is the input for the inverse function. How about now? Is it making sense? Okay.
So that means you can use 3.
You can use 3 too.
So it's just x.
So over here, we're taking the tangent inverse of both sides. We get x equals tangent inverse of 3. So really good question to go over. And now that we're a few days away from talking about inverses, that was in the last chapter, but that's the reason we need this. But that's also why we talked about domain and range. And I told you didn't have to memorize what the graph looked like, because you've already got a lot of new trig graphs in your mind, and nobody asked you to graph the trig functions, although tangent's the easiest one to graph. So in this sense, showing you a visual is good. I would have a really hard time graphing arc sine or arc cosine, because they're this weird sideways widget that I would have to make an XY chart for. It would take forever. But this one's easy. And you can see it's all real numbers for the domain of the inverse function. This being the inverse function, or tangent inverse, or arctangent. So you're familiar with all of those variety of things. So 22. I don't know the answer. And if you had a completely different problem and it said arctangent of the square root of 3 over 1, if you put that in a calculator, you'd find some decimal approximation for one of the things we know in the unit circle. Like if you didn't come to you, you could still figure that out. But tangent has anything.
I just knew that we only got like over 1 for sine or cosine, and we didn't do it, so I just wasn't sure about that.
Right. But the graph is different. Okay, so that was 22. We also have 60. Any before 60? 30, 30? Okay. Okay, so this one has the identity right here that we need to swap it. What is the word I'm looking for? Switch out, swap out. I tried to make switch and swap the same word. That was awkward. Okay, 5 sine of x minus 3. So tell me about sine of negative x. Is it even or odd? It's odd. That means that on the negative side of x, instead of the graph going up, the graph goes down. It's opposite sign of regular x. And it's on our sheet. Like it says on our sheet, sine of negative x equals negative sine of x. Because it's odd, because it does this, again with the picture, sine does this, where if you folded it and folded it again, it has symmetry to the origin. Positive values over here equal to the negative value over here. So if this is positive, it's equal to the negative at the same value. Okay, so it's an identity. Now we have negative 6. If you move the 5 over, oops, that won't work. Hold on. There we go. Negative 6 sine of x equals negative 3. sine of x equals 1/2. And then how many places does sine equal 1/2? 2. Sine is positive here and here on the top. So sine is 1/2. That's this one and this one. These are not. This is more like Pac-Man going up, waka waka. So this is x equals pi over 6 plus 2k pi. 5 pi over 6 plus 2k pi. 30. So an identity. We're moving to 60 now? Okay. So this is something we talked, I don't know when we talked about that. I don't know. I start them on that sheet. You don't really have much in the way of identities today. It's can you solve stuff and figure out the k-pi's. This is a quiz, so I'm just like y'all catching up. Yep.
So for 30 could we have also put pi over 6 plus k pi?
No, because k-pi would be this point.
Oh yeah. But then like could we just put pi over 6 plus 2k pi and then not put 5 pi over 6, or do we have to?
So in order to get from this point to this point, you can't get to this point by adding a value and then get from this point to back to this point by adding the same value. This distance is shorter than this distance. You have to list them separately. Does that help?
If it was just k pi, then you list one.
If they're directly across from each other, you can just list the one. But that only happens when you have all four in sine.
Yeah.
Or it's tangent, because tangent is the same sign in opposite quadrants. Yeah. Okay, 60. 2 sine squared x plus 3 cosine x minus 3 equals 0. So this is the identity you have to know. What is it? So it's the same one, rearranged. It's what Madeline said. It's what Zach said. And Ben said it's the Pythagorean theorem rearranged. And you have to do that so you're all in the same trig function. So now we have 2 minus 2 cosine squared x plus 3 cosine x minus 3. Negative 2 cosine squared x plus 3 cosine x, and then I've got minus 1, right? Okay, I can't factor that. I break at this point. So I'm going to multiply everything by negative 1, even the 0. As long as I multiply everything by the same number, I'm not breaking any math rules. So this is positive now, this is negative, this is positive, and now I should be able to factor it because I'm going to have a 2 cosine of x. 2 is either 2 times 1 or 1 times 2 times cosine of x. That makes 2 cosine of x squared. 1 is 1 and 1, that's it, right? They're the same sign. They're opposite signs. I didn't really have to think about factoring this at all if you got the rules, if you can just pull them out of your Algebra 2 hat. So cosine of x equals positive 1 over 2. Cosine of x equals 1. Cosine is positive in which two quadrants for this one? 1 and 4. So a half for cosine is pi over 3. Pi over 3. This is, thank you. And then, are they directly across from each other going through the center? No. So they each have to have a 2k pi. Okay, this is Pac-Man. It doesn't work. I'm trying to give you some visuals. So, and then I solved the 1. Where's cosine equal to 1? It's just one place. It's at 0. So we have only one place. And to get to that one place over and over again, we're going to have to add 2k pi. So you could call it 2k pi. 0 plus 2k pi. You could call it 2k pi. Either one is the same. And there's 3 answers. Yes.
So it had us do it in the interval 0 to 2 pi. So
Okay, so we would just list pi over 3, and it was 0 with a hard bracket, so 0, and then 5 pi over 3.
would you list 2 pi?
Well, it would have given you this.
Oh, okay.
So if they're saying don't list it twice because that's like duplicate.
Why is it only 0, 1?
It's not. It's 1. Because over here is -1.
Oh, yeah.
It's at 0. Right. We were looking 2 different zeros. All right. So, yep. We've got plenty of time. There's only 4 questions. They're not the hardest ones. 2 are multiple choice, 2 are free flying. Okay. Zach says go for it. Any seconds?